Good morning, all. First of all, let me thank Dr. S. Thangavelu, sir, for inviting me for this faculty development program sponsored by AICT Atal. And hope I'm audible. The participants, organizer, the organizer.
Yes, sir, you are
Yeah.
audible. Yes, sir,
Thank
you
you.
are
Thank
audible.
you. So, as I was saying, I'm thanking Dr. Thangavelu, sir, for inviting me. And also, I thank all the faculty members over here and the research scholars for being here to hear my presentation. The agenda of my presentation goes like this. I'll be talking on the basic introduction of electric vehicle technology, the need for electric vehicle technology. As you all know from the speakers who spoke during the inaugural session, the importance of electric vehicle and the aspect of multidisciplinary point of view in terms of electric vehicle technology, etc. And I'll be touching upon some of the research aspects in electric vehicle technology. How an electrical engineer or how a power electronics engineers can contribute to the efficiency improvement or technology of an electric vehicle. So if you go to the introduction of electric vehicle technology, and as the people used to say, this is going to be the cars of the future. By the year 2030, most of the cars in India or in the world will be of electric vehicle, powered by battery vehicle, battery or powered by any forms of technology other than the conventional fuel sources like petrol, gas, or the diesel one. Okay, so the reason behind that is it won't create any pollution and it is very silent, and also it can act as a self-independent in the case of energy. So, but in the development of electric vehicle technology faces so many challenges. Out of that, the three main challenges is like the battery package of the car. And it has a very limited driving range, and it requires long charging time, and the initial cost of the electric vehicle is very high. So the primary thing is the battery package should contain both energy in order to have a long drive range, and it should also have the sufficient power capability for acceleration and deceleration like the conventional vehicle. Assuming that you are uphill, you are driving uphill, it should have the capability to accelerate well. At the same time, it should be in a position to decelerate as well, taking into consideration the high current carrying capacity. All those things has to be withstand by the corresponding motors or converters used in electric vehicle. So in order to estimate the entire power consumption or the energy consumption of an electric vehicle, we need to properly model the components involved in the electric vehicle technology. So it is nothing but a trade-off. It's like there are so many components involved in electric vehicle. If you increase the number of components, assuming that the energy consumption can be increased as well at the cost of increasing the driving range. So the primary energy, electric vehicle components are the transmission, electrical machine, power electronics, and battery. And each and every component has to be modeled properly in order to avoid wrong decision, or otherwise in a positive way, in order to increase the efficiency of the each and every component, and in total to increase the overall energy consumption can be reduced or efficiency can be increased. So the design or rating of each component is a difficult task, as the parameters of one component is interlinked with the other components as well. So there is a risk in that one component can be rated in an inappropriate manner, which might lead to decrease the efficiency of the other component, or it may lead to increase the overall cost of the other component. So these primary component has to be modeled properly for two things. One is for increasing its efficiency, as well as to reduce the energy consumption of the individual component. So if you see the e-vehicle, I have another slide which shows you the history of e-vehicle. People started to use the electric vehicle in 1900s, but this electric vehicle concept started a boom only in the year 1970 and the year 1990. In the year 1970, there was an oil crisis in the world. Similarly, there was an oil crisis during the Gulf War in the year 1990. So then people started to think of an alternate way of transportation, like because the primary sources we have used it enough. The primary sources being the coal, petrol, and gas, we have used it enough, and we want to go for an alternate way of using these primary resources, either by not using it or by going for an alternate way. The reason behind that is, one is that oil crisis, and the second one is it will create a lot of pollution, and it will have a lot of emissions, carbon dioxide emissions, as well as it will emit a lot of SOx and NOx gases. So all these things has to be eliminated by introducing the concept of electric vehicle. If you see the benefits of electric vehicle, of course we can reduce the fuel usage and it will have almost zero emissions, and we have fuel flexibility, like I can depend on the conventional grid, or otherwise I can depend on my own home, and I can charge my vehicle, and it has a very good performance in means of if you have a sophisticated electric vehicle, the performance of electric vehicle is super good. And only consideration what we need to consider is the purchase cost. The initial investment cost is very high. In this point, we engineers has to focus. So as I said, the benefits of driving electric vehicle is I can save money. Second, I can get the clear air, and it is energy independent vehicle, and of course I can go for a jolly or enjoy the ride, because I'm not spending much money on the conventional fuel, and I'm depending on my own self for fueling the vehicle, so I can also enjoy the ride. So as I said, if you go back to the history of electric vehicle, it was started in the year when the rechargeable battery was invented. It was in the year 1859, in the lead acid battery was the first rechargeable battery was invented. And in the year 1899, there was a speed limit has been like almost 100 kilometers per hour. In the year 1902, first mass-produced electric car was introduced. From the year 1902 to till 1920, people believed only in electric vehicle technology. But after the invention of ICE, internal combustion engine, people they have moved their focus to ICE instead of the electric vehicle. Because in the case of internal combustion engine, I have the flexibility of going at a very high speed, and I don't need to bother about the deceleration and acceleration. I can stop or park the vehicle whenever I want, and I no need to recharge it again and again. And I have more bunker, more fueling stations, so that I can fuel it very easily. Apart from that, the speed of the speed of the conventional vehicle is very good when it is being compared to the electric vehicle. So as I said, till 1970, people were using only this electric vehicle technology. And again, after the 1970, again, there was an oil crisis, and people started to think about again this electric vehicle. And in the year 1997 until today, there are so many electric vehicles in the market. So if you classify the types of electric vehicle, it was started in the automobile starting system, right? Like I think many of you have used the car Maruti Esteem. The example I'm saying Maruti Esteem, the automatic start-stop system. That is the starting stage of the hybrid vehicle system. So internal combustion engine, that is the conventional vehicle, and after that the small automation was introduced in the conventional vehicle in the starting of the system itself. That is called as a micro hybrid. And later on, people have have developed an inbuilt motor to it. An electric motor can support the ICE. That is nothing but a mild hybrid. Then the combustion engine also combined with an electric motor. So that we have two sources of energy. Then it can be called as a hybrid electric vehicle. Completely engine has been eradicated, and full battery source was kept inside the vehicle, so that the motor can run with the help of the battery, and it can be charged with the help of a plug-in system. Then it is called as a plug-in hybrid electric vehicle. Similarly, the plug-in electric vehicle can be supported by an alternate sources of energy sources like an ultra capacitor, super capacitor, fuel cells, compressed air energy storage system, flywheel mechanism. Then it can be called as, I can extend the range of electric vehicle, driving range of electric vehicle. Then it can be called as a range extended electric vehicle. Similarly, this entire electric vehicle can be fueled with the help of fuel cell, or completely I can believe only on alternate energy sources. Then it can be called as a full electric vehicle or a battery electric vehicle. So this is the different classifications of electric vehicle available in the market now. So you can see these are all the electric vehicles you would have come across in your day-to-day life. All the locomotives, golf carts, forklifts you might have seen in the process industry or any kind of an industry, where in which it can be used for transporting goods from one place to another place inside the building itself. So those elevators, we can also call it as an electric vehicle, because elevators, it moves people from bottom surface to the top surface, and it can be moved with the help of a motor. For example, if you take Burj Khalifa, the entire from the ground floor to the top floor, the skyscraper, the top floor, the entire building is being operated by an elevator, and within 1 minute you can go, you can reach the top of the vehicle. So that is the point. The point here, what I'm trying to stress is the kind of motor you use to lift people from one surface level to the higher surface level. Okay, so presently the kinds of electric cars available in the market is what I have shown in the figure: hydrogen fuel cell, solar racer. The complete system is being powered by solar PV system, and a hybrid vehicle, neighborhood electric, MIT city car, full size battery. There are kinds of electric cars available in the market. I have shown you a sample, and of course, excuse me. Hello.
Sir, your PPT is not visible, sir.
Oh my God. From which point?
Just 2 minutes back, sir.
Sir, visible, sir. Just click another name.
Okay.
Is it visible now?
Now not visible.
Oh, was it not visible right from the beginning or only from now?
No, sir, it is visible, sir. Some other click to present side by side.
You please lock it so that others won't disturb.
Okay. Thank you, sir.
Is the PowerPoint visible now?
Yes, sir.
Okay, thank you. So if you see again the history of electric vehicle, this slide I specifically inserted to show one particular point. Like as I said, in 1830s itself, the people started to use this electric vehicle. And if you see the third point, the first speeding ticket was issued to an electric car driver in the year 1904. This point specifically I mentioned the capacity of the motor they have used even in those periods. Okay, so in 1910, mass production of EV car by Ford cars was introduced into the market, and as I said, till the invention of ICE engine and till the particular point, people were only believing in this kind of an electric cars. So the corresponding two slides will be very interesting to you people. In the year 1968, there was a great electric car race. It was a milestone in the history of electric vehicle. There was a great electric car was between MIT, Massachusetts Institute of Technology, and California Technology. And during that is nothing but a transcontinental race. Okay, it was between two universities from MIT to Caltech. During that time, there were 53 charging stations was used, spacing 60 miles apart. And the batteries used in this car were nickel cadmium battery. Okay, and in the year 1970, there was a clean air car race. So even during that time, people have used almost all the technology people now using. Like 50 plus car raced from MIT to Caltech using many alternate sources of powertrains. For example, California Technology, they have used induction motor, AC motor inside the car so that they can use the concept of regenerative braking. And Boston Electric Car Club, the Boston University, they have used the technology of battery swapping. The battery swapping methodology is being used in the present public cars, public vehicles. And Toronto University, they have used a parallel hybrid design, where similar to now the Toyota Prius architecture, they use parallel hybrid design. I'll tell you what even a parallel hybrid design later. And MIT, they have used series hybrid and electrically commutated motor. The purpose of this particular slide is you please Google the clean air car race. I have given the source here also. Almost all the technology was being used, but that was in an infant stages of research. You people still can do some research on this particular technology, and you can implement, re-implement, or retrofit some of the technologies presently we are using it now. So the need for electric car and hybrid electric vehicle, as I said, main focus is the environmental concerns and practical concerns. Environmental concern is we engineers bothers about the mother nature. We need to bother about the global warming and greenhouse gas emissions. And so we are not going to use the ICE, which is being supported by petrol, diesel, or gas, and instead we'll be using the electric vehicle with, using the vehicle with the help of an electric technology. Nowhere it can be called as the mechanical engineer's brainchild or automobile engineer's brainchild. It will be a combination of, as the registrar said, this will be a combination of a product which is from the engineers of electrical engineering, mechanical engineering, electronics and communication engineering, and ICT. Okay. In practical concerns, as I said, we no need to believe in the conventional fuel. Instead, we people can also become a prosumer. Like I can also produce energy out of the car, what I'm having, and I can supply the energy generated from the car to the grid. That I will discuss it later. That concept is called as the vehicle to grid and grid to vehicle technology. So these are all the practical concerns and requirement of electric vehicle technology in the present world. So the benefits we have seen already. And this is the basic structure of a hybrid electric vehicle. So hybrid means any vehicle which can run with the help of two sources. That can be any source. For example, some of the cars which are in the road now, they can have petrol as well as gas as a fuel source. Even that vehicle can also be called as a hybrid vehicle. If suppose the internal combustion engine combined with an electric motor, then it can be called as a hybrid electric vehicle. But as a technical term, hybrid vehicle means it consists of ICE plus electric motor. So this is the basic structure of an electric vehicle, or hybrid vehicle. And if you see the architecture, this slide is very, very important for the researchers and the faculty engineers. And if you see the architecture of an electric vehicle, if you see the, I hope my pointer is visible. If you see the architecture, the particular transmission is being given energy by means of an electric machine. Okay, and electric machine will be given supply through an inverter, and the inverter can be supplied with the help of a grid. Okay, grid means it can be charged by means of a battery, or otherwise it can be the machine can get its energy from the grid. So I'll be having a rectifier. It will be boosted to a particular voltage which is suitable for supplying the battery as well as for supplying the auxiliary loads. And from the battery, it will be given to an inverter. Inverter in turn supplied to the electrical machine, and the machine will run the vehicle. So this is how a machine will work. If you see the purpose of each and individual blocks, it is a research for us. For example, if you take the electric machine, I can use 1 to 4 types of electrical machine here. For example, I can go for a DC machine, I can go for a BLDC, I can go for an AC induction motor, etc. Or otherwise, I can take a small motor with the gearbox, or otherwise without gearbox. Or otherwise, I can go for a very, very low battery voltage, low voltage battery, like 12 voltage battery. I can boost it with the help of power electronic converter. I can use it for running the motor. If it is in the case of an AC motor, I need to go for an inverter. If it is an inverter, or if it is in the case of an AC motor, whenever I apply a brake, that braking energy can be used for charging the battery with the help of a braking resistor, etc. That is called as the regenerative braking. I hope this architecture is clear for you. So each and every block plays a major role in increasing the efficiency of an electric vehicle. If you see the traction power of the vehicle, it is being delivered by this electrical machine. And the torque of the left and right wheel will be provided either by means of a gear ratio, or other by means of a shaft which is being powered by a motor. Okay, gear machine can be used, a gear box can be used for going for a higher range of speed, like 1:, there are many 1:10, 1:100. There are many different range of gearboxes are available based on the motor you use. And here the torque and speed of the machine can be controlled by an inverter. Okay, or otherwise, if in the case of a DC motor, the torque and speed of the machine can be controlled by a DC motor controller. Okay, and the rectifier, as I said, which can be used for boosting for the required voltage, and also this braking resistor is used for regenerative braking concept. Fine. If you see the control of hybrid electric vehicle, as I said earlier, any vehicle that contains one or more power source. I specifically represent one or more power source because in the future I can have the fuels as supercapacitor, fuel cell, battery, and also I can have ultra capacitors. And each and every sources can play a particular role in giving energy to the motor, then it can be called as a hybrid vehicle. So the first patent of hybrid electric vehicle technology was filed by an American scientist, H. Piper, in the year 1905. As on date, there are so many concepts available. In the year 2000 itself, there were around like 23 patents were filed for this hybrid electric vehicle concepts. So there are several configurations are available. For example, electric vehicles equipped with electrical battery, one source, and a super capacitor. Then it can be called as a battery electric vehicle, or otherwise hybrid electric vehicle combined with IC engine, petroleum fuel, and it can be powered by battery or a super capacitor. Okay, then it can be called as hybrid electric vehicle. Or the entire vehicle can be equipped with different types of fuel cell. Now in the market, PEMFC, proton exchange membrane fuel cell, is very prominent and very good, super good. Then that can be called as a fuel cell electric vehicle. And controlling of this vehicle has many things, like this is almost like a trade-off, whether I can invest more money or I need efficiency, or I can bother only about the energy consumption. Based on that, I can choose proper control mechanism. So it all depends upon the autonomy of the vehicle. Autonomy in the sense, without charging the battery, how long the battery can sustain. For example, let me charge the battery in the morning, 6 o'clock. If I'm able to run my car for 1 day without recharging it again, then the autonomy of the battery is 1 hour, 1 day, that is 24 hours. Okay, so if you increase the battery capacity, assuming that I have 2 batteries which can be used for powering the motor, then I can run the vehicle without charging it for continuous 2 days. Then my autonomy is 2 days. Right? Meaning is I have to have low autonomy. Meaning is I no need to recharge it again and again and again, so that I can reduce the time required for recharging the battery. So if you see the main components of electric vehicle, the main components of electric vehicle is battery, the type of port you use, and the type of DC to DC converter, electric traction motor, onboard charger, power electronics controller, and type of cooling system you use inside the car, and how you have a battery backup system, and how you transmit electric power from one component to the other component. So these components involve, if you see each and individual component, in all the components, we electrical engineers play a major role, except this thermal system. Okay, you leave the power electronic component, cooling part, the entire thermal system has to be installed by a proper mechanical engineer to avoid accidents, mainly for safety aspects. Of course, controlling, mainly for providing safety to the components of the electric machines as well. So this slide is very basic slide. This will tell you how an electric car works. So as I said, this is the wheel and this is the differential transmission system and this is the motor. This motor you need to run with the help of any kind of a fuel source. You can run it with the help of a battery or you can run it with the help of any sources. Here what I'm doing, I'm going to control the motor. For example, if I want to increase or decrease the speed, I am using a motor controller. So I have a speed pedal. That is nothing but the accelerator. Then this motor can be given power with the help of a motor controller through a battery. And the battery can get its charge from a charger. Either this can be a plug-in type or otherwise we can get it from a grid. Okay. And for supplying power to the auxiliary load, you have a DC to DC converter, and for that you have an auxiliary battery. And apart from that, you have other switchgear component like contactors. Right. So see, I have shown here only the contactor. Apart from that, you will be having a fuse, you will be having a relay, you will be having a switch, you have a starter, everything will be attached to the controller itself. Fine. Sorry. So this slide will tell you the working principle of an electric vehicle. So this is the conventional vehicle. We have a fuel, we have an engine and a transmission system. And in the case of a hybrid vehicle, as I said, apart from these 2 blocks, you will be adding one more block, which will be supported by a battery, motor generator set, and a battery. Here, the motor will be powered by the battery, and it will run the transmission system. So once it is getting fully drained out, it will again recharge with the help of this motor generator set. Okay, so this should be an AC motor in that case. And here you have again a motor generator set, and completely I have eradicated this fuel engine. So this is nothing but a battery electric vehicle. So this is the conventional vehicle, this is the hybrid electric vehicle, and this is the battery electric vehicle. Okay, and if you see the structure of the hybrid design, the structure can be classified into three types. So based on the types, you need to add the drivetrain components involved in the electric vehicle. So these drivetrain components play a major role, because whenever you increase the number of components in an electric vehicle, we need to bother about the wear and tear of the machine. We need to bother about the individual efficiency of the component. So for example, if you take the series hybrid system, so here the power will be transmitted via motor, and motor will be controlled by an inverter, and inverter will be supplied by a battery. So this will be a series flow. And in case if I have a support of an engine, the engine will be given power to the generator, generator will be given power to the inverter, and again the entire system will be operated only by means of a motor. Then it can be called as a series hybrid design. In the case of a parallel hybrid design, you have a motor, inverter, motor, generator set. Apart from that, if at all, if there is no power, no charge in the battery, then this engine will take over and it will help in transmitting the system. Okay, and you have a corresponding reduction gear or gear mechanism, etc. So each and every structure has its own advantages and disadvantages. Apart from that, like as I said here, this is nothing but the series configuration and the parallel configuration. Depending on the requirement and depending on the number of drivetrain components involved in an electric vehicle, you can choose any kind of configuration. Apart from that, we have one more configuration called a series parallel hybrid system. Combined, we are taking the advantages of both series and a parallel, and we are using it for a particular vehicle. But it involves a lot of drivetrain components. If you see in the figure, battery, inverter, motor, and again we have an engine and it will run it. And apart from that, this engine will also support through the generator to the inverter. So this is nothing but a series parallel hybrid system. So this animation will tell you the working of an electric vehicle. So this is a conventional electric vehicle wherein which electric motor supplied by a battery through the plug-in, by means of a charging method, I can charge the battery and I can run a motor. But if you take a plug-in hybrid electric vehicle, so here, so this is the hybrid electric vehicle. I'll show the plug-in hybrid electric vehicle in this block itself. You leave that previous slide. So gasoline engine will run a combustion engine and electric motor generator set. Correspondingly, the generator will charge the battery. And once the battery gets fully charged, whenever it reaches the terminal voltage, the entire part will be supported by the motor alone. Okay, and again, once it gets drained out, the combustion engine will take charge, and it will help for transmitting the system. And again, the process will be recycled. But in the case of a plug-in hybrid electric vehicle, the entire battery is being replaced by additional battery, and it will be charged with the help of a plug-in system. So this is called as a plug-in hybrid electric vehicle. And in the case of EREV in the essence, extended range electric vehicle. So we can use alternate battery sources. For example, instead of the conventional battery, we can go for 15 kilowatt hour of energy, so that I can go for an extended range of driving. So this is nothing but plug-in hybrid electric vehicle and extended range electric vehicle. So this slide is very, very important. This will tell you the type of technology we can use in the case of electric vehicle. So each and every hybrid electric vehicle is distinguished from a standard ICE driven by 4 different parts. For example, a device to store large amount of electrical energy. For example, I can go for a battery. I can go for a supercapacitor. I can go for an ultra capacitor. I can go for flywheels. I can go for CAES, compressed air energy storage system. I can go for PEM-FC. So depending upon the type of the sources I use, I can classify it. Second, depending on the electrical machine to convert electrical power into the mechanical torque on the wheels. For example, here in this motor, I have used DC motor, or induction motor, or permanent magnet synchronous motor, or I can go for a BLDC motor, or otherwise I can go for a switched reluctance motor. right? So these are all the range of motor we can use it. Tesla people use induction motor because of the concept of because of the advantage of having regenerative braking concept. Even though DC motor is having the advantage of controlling the speed very easily, but it has a very big disadvantage of it gets heats up very easily, and it will spoil the corresponding components involved in it, and it requires a lot of maintenance. And the current trend is people started to use of BLDC, brushless DC motor. Another current trend is people started to use of SRM, switched reluctance motor. The purpose of switched reluctance motor is it can respond even at a minimum input. And the disadvantage, the point is the response time of switched reluctance motor is super good. Okay, but the disadvantage of SRM is it has a high torque ripple content, and you need proper what do you call different types of pole configurations are available. You need to choose the proper pole configuration to mitigate the problem of torque ripple. So, but the controlling of SRM is very easy, and it also has an advantage of it can even respond at a very low input. Okay, so it almost depends on each and every motor has its own advantage, but it's again depends on how much you invest money and what type of motor control algorithm you use. So coming into the topology, I can choose the motor first, and depending on the topology, I can go for DC to DC converter, inverter, and multi-level inverter, right? And again, in the topology, I can go for MOSFET or IGBT. Apart from that, the present driving electric cars, people started to think about GaN and SiC devices, gallium nitrate and silicon carbide devices. Okay, so the purpose of using GaN and SiC is having high energy density, which is very much required for an electric vehicle. So if you take a conventional electric vehicle, you leave the concept of electric vehicle, you take the conventional car, and if you try to measure the current carrying capacity during the starting of the system, it may go up to 1000 ampere DC. So if you are trying to use an electronic control unit for your conventional car, that particular electronic control unit should have the capability to accept that 1000 ampere during the starting time. So what I'm trying to tell is the switches what you use should have high energy density, high power density, so that it can be used for, so that it can withstand the high inrush current during the starting of the system, during acceleration, etc. Okay, and as I said, the type of energy storage system also varies. And the main point here is how you control the entire system. What type of control algorithm you use? Whether I'm going for a triple VF or FOC or DTC or NeuroFuzzy or FLC or PSFAM. So depending upon the control algorithm, I can classify the technology, I can classify the method I can control the electric vehicle. So choosing the software, then I have to bother about the hardware. Whether I can go for a microprocessor unit or a microcontroller unit, or otherwise a simple DSP or a DSC or FPGA or ASIC design chip. So based on the control algorithm, I can go for a hardware. So this particular slide will give you a clear picture in which you people can concentrate on your research. So another point which I want to add here is, assuming that you want to develop a vehicle, you want design a vehicle. So the main focus you need to concentrate is how much should be the load carrying capacity of the vehicle. So once you decide the load carrying capacity, you have decided the weight. So once you have decided the weight, then what force is required to move that weight from one place to another place? That is nothing but F is equal to ma. That is nothing but a linear force. But what we want to calculate is the rotational force. That is nothing but the torque. So the torque, once you decide the torque, then you can design the motor, right? Hope you people can understand what I'm trying to tell you. So the first thing what you want to decide is you need to calculate the weight requirement. So the main research focus is on how to reduce the total weight of the car. It almost like I need a Kevlar bulletproof material. Meaning, what is the purpose of bulletproof? It has high strength, at the same time the contradictory factor, low weight. The same material, I mean the same concept is required required for an electric vehicle. It wants all the sophisticated system in the car, but at the same time not at the increasing the total weight of the car. If I increase the weight of the car, then I need to increase the torque requirement. Then I need to put more battery, more capacity. Meaning is the more HP. Then I need to invest more on my battery. Then it takes more charging time. Then there will be complications in the converter, controller, etc. So the main focuses should be on how to control the total mass of my vehicle. I hope I have clearly explained to you the concept of the components involved in an electric vehicle. And again, here I have given you the architecture of hybrid electric drivetrains. Before I move further, I just want to inquire if you have any doubts, I can clarify now, or otherwise I can move on to the next slide. Participants, organizer, if you have any questions now, I am ready to answer, or otherwise I can move on to the next slide. Any doubts so far? Hello? Organizers?
Yeah, proceed now. Proceed, sir. No.
Okay, thank you. So as I said, I have explained to you now the different different components involved and what are the motors used in the hybrid electric vehicle, etc. And if you see the architecture of hybrid electric drivetrain, it can have 4 different kinds. Like it has series hybrid, parallel hybrid, series parallel hybrid, and complex. And depending upon that, I can choose my electric vehicle sources. Like I can have ICE or a generator, and I have a PWM converter, a battery, and a motor, a transmission system, and the conventional method. So this is the architecture of hybrid electric drivetrain system. Okay. So as of now, what I have discussed is I have given you the introduction of electric vehicle, then the components involved in an electric vehicle, and what are all the classification of electric vehicle, and what are the topologies in electric vehicle, etc. So being a design engineer, the major requirement of hybrid electric vehicles are it should have high instant power and high power density. So the first point can be compensated by introducing GAN and SIC devices, and it should have high torque at low speeds for starting and climbing, as well as a high power at high speed for cruising applications. So this particular point can be achieved by having a suitable control algorithm for the inverter. Okay, yeah, and it should have a very wide speed range, including constant torque and constant power regions. You know, the 4-quadrant operation in an inverter. So that will be also achieved with the help of an efficient design of an inverter. And it should have a fast torque response. If you choose a particular motor, that motor should respond it immediately. This is where the importance of SRM comes into the picture. A high efficiency over the wide speed and torque range. If you increase, even if you increase the speed, even if you increase the torque, it should have high efficiency. And high efficiency for regenerative braking. Meaning whenever you apply a brake, for the conventional vehicle, whenever you apply a brake, fuel will be consumed more. Instead, if you apply a brake, it should have the capacity to use its energy in a very good manner by means of regenerative braking concept, so that it can recharge the battery whenever you apply a brake. And it should have high reliability. Reliability is a very, very important concept in an electric vehicle. This itself is a separate topic for research, and it should have high reliability and robustness, and at the very, very reasonable cost. Even though it has all the features, I have to give it to the customer in such a way that they should be in a capacity to buy it. Okay. The current areas of research, as I said, I need to increase the overall mass of the vehicle and decrease material and manufacturing cost. I have to improve the hardware, and I need to go for an alternate way of batteries. For example, the present, if you take the Tesla car, they are using lithium-ion battery. Even though metal hydride batteries are more efficient, but it also again a trade-off. Whether I have to bother about the charging method or I should bother about the cost. So based upon that, I can go for alternate different ways in which I can go for a battery system. So nickel metal hydride, I have given the properties of it. I can leave it. And the degrees of hybridization can be classified by 5 methods. Automatically stops and starts the engine in stop and go traffic, then it can be called as the micro hybrid. Okay, if it uses regenerative braking and it uses an electric motor, then it can be called as a mild hybrid. And it can drive only by means of electric motor, then it can be called as a full hybrid. And if it has rechargeable battery or otherwise an extended range of system for fueling the motor, then it can be called as a plug-in hybrid. So these are all the different degrees of hybridization. Whenever you increase the degrees of hybridization, the complexity will also get increased, so that the drivetrain components will also get increased. So the electric vehicle types, we have plug-in hybrid electric vehicle, extended range electric vehicle, battery electric vehicle. So all the vehicle types are available in the market. And if you see the energy loss calculation, normally we used to have a heat mass balance calculation, right? Similarly, for being an electrical engineer, we need to calculate the energy loss calculation for city driving as well as the highway driving. So if you go for a city driving, the energy losses will be, assuming that 100% efficiency in the fuel, I have some losses in the standby, engine loss, driveline losses, and these are all the drivetrain component losses. Driveline is nothing but drivetrain component losses, and I have vehicle related losses, like whenever I apply brake, I lose 6%, and during gyros I lose 4%, and during arrow I lose 3%. So these are all vehicle related, and this vehicle related losses will increase day by day because of the wear and tear of the machine. And these are all the powertrain related losses, and that mainly focuses on the design aspect of the engine or design aspect of the vehicle. So during the highway driving, the same vehicle will have different efficiency range. Like the standby loss I can reduce, because in the highway driving I no need to stop the vehicle, I no need to bother about the traffic, no need to bother about the traffic signal, etc. Engine losses only 77, driveline losses 4%, and vehicle related losses will vary. But if you take an energy saving hybrid system, I can remove the standby loss if I introduce the micro hybrid. Okay, and if I remove the braking system, then the mild hybrid can be introduced. And full hybrid can reduce this engine loss, right? Because I am going to use only the motor. Okay, so these are all the different ways in which I can eliminate the losses in a vehicle. Okay, so this is the energy balance diagram for an electric vehicle. So if you have a battery, motor loss, now people are talking about IE4 motor, wherein which you can get an efficiency of 99%, so that even this 10% loss can also be minimized. And the driveline also losses can be minimized only by means of efficient design of a power electronic converter. So I have 14%, but because of the introduction of GAN and SIC devices, again these losses can also be reduced. If you compare well to wheels efficiency, the first one is like a generation, transmission, distribution, and it can be utilized with the help of electric vehicle as a load. And in the second part, it will go to the refinery, transportation, fueling station, and I can fuel the vehicle. If you compare the efficiency, GTD losses, we know about it, and we have around like 23% efficiency. In the case of refining transmission, we have an efficiency of so much, and it can have only 13% efficiency. Okay, so this is the comparison between the conventional motor and an electric vehicle, an electric motor. So electric motor, we have a 23% efficiency. Of course, this efficiency can be increased, but as a thumb rule, I'm saying that because, for example, if you reduce the AT&TC losses, correspondingly, if it is within the limit of 15%, this efficiency will get increased. Okay. So now we have discussed about the components involved, the type of motors, etc. And one more important topic in the electric vehicle technology is BMS, battery management system. Like if you want to know about the battery management system, you need to know about these corresponding factors. That is state of charge, depth of discharge, state of health, capacity, energy, specific power, and autonomy. Autonomy, we have discussed it earlier. State of charge is something like it has to be expressed in terms of percentage, and what is the maximum capacity of the battery in which it can be charged. If you have a 24 voltage battery, it has to be charged to 24 voltage, and once it reaches 24 voltage, it has to be discharged. I mean, it has to be disconnected. And how long it will take to charge from the terminal voltage. If it is a 12 voltage battery, the terminal voltage of a 12 volt battery is 10 voltage. So how long it will take to charge? So these factors will decide the type of charging system. Now people are talking about turbo charging, okay, fast charging, and there are many ways in which I can charge it very quick. Now, if you go to the conventional electric vehicle available in the market, it takes minimum 15 to 20 minutes for charging the battery. Assuming that during the morning rush hour, if I take 15 to 20 minutes to charge my vehicle, and then if I go to my office, people won't prefer electric vehicle. So what I need to do, I need to design BMS in such a way that it has to charge within no second. People are now trying to charge electric vehicle within 2 to 3 seconds, 2 to 3 minutes, okay, not seconds, 2 to 3 minutes, 5 minutes maximum, 15 minutes maximum. So there are many ways in which I can alter the charging methodology. Then only the people will, because if you go to a conventional fuel vehicle, assuming that particular person is taking 15 minutes to fill your fuel tank, you will be impatient and you won't again go to that particular fueling station, right? The same concept in the case of electric vehicle. So if I have an electric vehicle, if it gets charged within no second, then many people will come into the market and they will play a role until they will buy the electric vehicle. Here comes the importance of an electrical engineer. What happens in a particular bunk, in a particular charging station, all the vehicle come and charge at the same time. Then I need to bother about the DSM concept, demand side management. How my load profile will vary in the morning hours, in the peak hours, in the night, in the afternoon. Okay, so how my grid should respond to that load profile. So this is where we researchers have to concentrate on BMS as well as DSM. So main objective of hybrid electric vehicle is maximum. These are all the member function in which we need to use for optimizing the efficiency of the electric vehicle technology. So maximum fuel economy, minimize fuel emissions, minimize propulsion system, so that I can reduce the cost, maintain acceptable performance like extended driving range, etc. Reduce the conventional car weight. So if I am able to do a part in any of this point, then if it increases the overall efficiency of the system, then it is a grand success. So hybrid electric vehicle advantages, I can do regenerative braking, reduction in engine and vehicle weight, fuel efficiency is increased, etc. This we have already discussed. Okay, fine. Now we come to the motor component. The main part of an electric vehicle is motor. So I have discussed with you about the drivetrain component. So what are all the components involved in the drivetrain? So in the drivetrain, we have electric motor and its corresponding controller and its switchgear component. Okay, switchgear component also plays a major role. For example, fuse is a very important part. Similarly, contactor is an important part. Without contactor, I cannot run a motor. How to start it? I need a starter and instead I need a controller. So I cannot directly give a supply to the controller. Instead, I need again a braking system, breaker, not a conventional breaker, right? So these are all the drivetrain components for electric motor and controller. And electric energy storage system. How I'm going to store it? Either I'll be using a battery or a supercapacitor or a fuel cell, etc. And I have a hybrid power unit. So these are all the drivetrain component which can be used for transmitting the vehicle, transmitting the power from the motor to the wheel. Okay, then I have a transmission system. In the transmission system, depending on the motor, I can have either a motor inverter set or a motor controller set or a motor gearbox set. So the purpose of having transmission system also as one of the component in drivetrain is whether I have a gearbox or not. Okay. So electric motor, as I said, the conventional forklift motor, the conventional forklift motor normally they use 96 voltage battery or 192 voltage battery. Okay, depending on the lifting capacity, they I can use either 96 voltage or 192 voltage. Here, people mostly they use DC motor. So the DC motor, I can go for lifting the intermittent system. It can accept acceleration and decelerations. Okay, but it has a limitation of it will get heat up very easily. Then I need to invest more on thermal cooling system, right? And it may lead to self-destruct when it heats up. Okay, so if I don't have a proper cooling mechanism during the long driving range, the usage of DC motor leads to a problem. So avoid using DC motor. Instead, I can go for other type of motor like BLDC motor, etc. Or otherwise, I can have an AC motor since it has better torque and speed output. And the overall weight of the motor for the same HP, I can get the reduced AC motor, and also it can use the concept of regenerative braking. So these are all the electric car motors used in the market now. Fine. So how to control this electric car motor? I have a DC, assuming that I have a DC motor. So the pedal accelerate or decelerate, and it have a controller, and controller will run the DC controller, and from the DC controller I can control the DC motor. So it's a very simple concept in the case of a DC motor. So I have a simple DC motor, and DC motor can be controlled with the help of a controller, and controller gets its input from the pedal. Okay, so this is very simple in the case of a DC motor. I can go for a PWM controller also in the case of a DC controller. But in the case of an AC controller, I need an inverter for controlling operation. From the pedal, I will go to the controller. From the controller, it will go to the motor, and it will go to the transmission system. So it requires an alternate auxiliary supply and a battery supply in the case of an AC motor. And of course, you know about the motor components. I can skip this. And motor controllers we have discussed, and energy storage system, as I said, I can go for lithium ion, nickel cadmium, nickel metal hydrate. Nickel cadmium is a very good battery technology, since cadmium is coming under ROS compliance, resistance of hazardous substances. That is nothing but ROS compliance. People don't prefer cadmium. Instead, people can go for metal hydrate batteries, ultra capacitors, and flywheels. So batteries, I can have different range of batteries, and I no need to talk about that because I have talked it enough. I have spoken it enough. Like nickel, this is the comparison which shows the importance of nickel metal hydride and lithium ion battery. And energy storage, ultra capacitor. See, present cars mostly they have ultra capacitor, and they can use these ultra capacitors during the acceleration, climbing hill, etc. And during the regenerative braking also. Battery will be there, and apart from that, you have an auxiliary source of an ultra capacitor. And whenever the vehicle is going uphill, or whenever you are accelerating it, and whenever there is a braking obligation, then the ultra capacitor will come into the picture. Because whenever you apply a brake, during that system, the battery is getting charged. So then the alternate source, the ultra capacitor will come into the picture and will run the motor. So these are all the battery, the importance of ultra capacitor. And flywheel, again, it is in infant stage. It can store kinetic energy by spinning a wheel, and it is complex, heavy, large. And advantages are it has no acid, and no need to bother about thermal cooling system. No need to bother about spillover, as it is in the case of a battery. No acid, not affected by the temperature. It delivers a smooth flow of power. But where to place it in the vehicle? So that is a very important point in the case of a flywheel storage system. Another thing is CAES, compressed air energy storage system, and again, it has no problem in the case of a heating and thermal system. I no need to invest much, etc. But again, the weight of the CAES is high, and where to place it in the car. So these are all the problems involved in flywheel and CAES. So people generally prefer ultra capacitor or fuel cell. Again, the disadvantage of using fuel cells are there are different ranges of fuel cells available. The fuel cells are available in stacks, and it occupies more space when compared to ultra capacitors or battery. And how I'm going to dispose the hot water which is being generated from the fuel cell. So that is an important factor in fuel cell. Fine. So as I said, the BMS. So now we have discussed about different technologies available for storage and the importance of BMS. So while designing the BMS, battery management system, we have to consider the following factor. How my battery will respond if it is running at a low speed for a very long range of time. Okay, and how my battery will respond for a city driving, because I need to apply brake frequently, and how my system will respond during highway driving, and how my system will respond during acceleration, and coasting, slowing, and stopping. You need to know the difference of these three. Slowing means I can drive at 30 kilometers per hour, 20 kilometers per hour, etc. Stopping means 0 kilometers per hour, completely park the vehicle. And apart from that, one more important point is called as the coasting. This we have come across during the control algorithm of drives, AC motor drive or DC motor drive. There we used to call it as an inching operation instead of a coasting operation. Coasting is nothing but whenever you press a button, it has to drive or it has to rotate. So that is nothing but inching or a coasting. So assuming that people are standing in a traffic signal, you will be driving the vehicle not at a slow speed or at the fast speed, but at the inching speed or at the coasting speed. Then it can be called as the coasting operation. So motor components, regenerative braking, how my system will respond whenever I apply a brake. If it is an AC motor, during a braking system, the energy won't spoil. Instead, energy will get regained and it will store it in a battery. And 4 types of motor component hybrid power units are there. CIDI, that is nothing but compression ignition direct injection engines, spark injection engines, gas turbines, and fuel cell. So these 4 hybrid power units are available in the market. Each and every vendor, they use either one of these type based on the type of the topology or drivetrain components involved in the electric vehicle. For example, so if you have a CD, most promising power unit, and it has it can withstand high pressure injection. So the conventional car, what you see now, they use this CD mechanism. And the spark ignition is a very old technology. It uses a Otto cycle. It is based on the spark ignition, that is plug. It has a spark plug. Okay. And a gas turbine, again, it runs on a Brayton cycle, and it has a compressor, raises the pressure and temperature of the inlet air so that the engine will get ignited. Okay, so this is also a very old technology. Apart from that, we have one more technology called as the fuel cells. Okay, it can generate electricity through a chemical reaction. And again, the problem in the case of a fuel cell is, as I said earlier, how to dispose the hot water which is being generated from the vehicle. Okay, and water vapor is emitted all the time, and we have a proper thermal cooling system to eradicate this problem. Okay, so either I can go for a CD or a gas turbine, or otherwise a spark plug or a fuel cell. Okay, the present electric vehicle, mostly they prefer CD system. And transmission, we have 4 types of transmission, like CVT. All the vehicle, the modern vehicle, they use CVT technology, continuous variable transmission. And of course, in US, people don't prefer CVT technology. People always prefer automated shift transmission. Compared to CVT, excuse me. Compared to CVT, automated shift transmission is quite costlier, because I no need to bother about the gear mechanism. Then continuously the gear change will happen automatically. Then it is called as the automated shifted transmission. And manual transmission and traditional automatic transmission with the torque converter are the very old method. Still people are using it, but people normally prefer either CVT or AAST. So these are all the things we have discussed. Fine. So now you come into the main part of my presentation, one of the main part of my presentation, the converter part. So I have discussed about different types of components involved in an electric vehicle and different types of motor which is being used in an electric vehicle. So I have different motors. How to control the motor, or how to charge the battery? Okay, in both the ways I need a converter. and how to give auxiliary supply to the auxiliary loads available in the car. Because car is nothing but an infotainment. It consists of information plus an entertainment. So to supply power to the information, like the ECU part, the airbag part, the braking part, etc., that is information. Entertainment is you have many things, right? Lighting system comes under information, etc. So the info plus entertainment is nothing but infotainment. And to supply the power to the infotainment and to run the vehicle, we need a battery as a source in the case of electric vehicle. So what we need is we need an efficient DC to DC converter which can give power to run the vehicle as well as to run the auxiliary load. So we want to have a proper DC to DC converter. So by introducing the DC to DC converter, one can choose the voltage variation of the device and the power of each device to be controlled. So when supercapacitor are the only storage system that may be too big and heavy. So to avoid supercapacitor, we can go for a fuel cell or a battery or a hybrid. Whatever the source is it may be, we need a DC-DC converter. So a conventional car, a conventional electric car, here after the conventional means electric car. Okay, so the conventional electric car power ranges from 20 kilowatt to 100 kilowatt. So this 20 kilowatt to 100 kilowatt, the properties of the parameters to be controlled are many. For example, the speed, the acceleration time, the torque, the power profile, the peak power, the continuous power, the current carrying capacity, the energy density, the specific power. So those aspects has to be calculated for designing the proper DC to DC converter. Fine. So this slide will tell you the type of power converters available for the electric vehicle. We have a range of electric converters available like AC to AC converter. Basically, it can be classified into AC to AC converter, DC to DC converter, AC to DC converter, DC to AC converter. So here we are going to concentrate primarily on DC to DC converter because the input source is battery. From the battery, either I can convert that into a high voltage DC, which can be useful for powering the motor, or that DC can be converted into AC, right? And AC EB can be used for supplying the motor. So I have majorly the primary focuses should be on the DC-DC converter. So the DC-DC converter, we have buck converter, boost converter, interleaved converter, and a multi-level converter. Okay, so again, this DC-DC converter can be classified based on two factors. So before going to the next slide, here this AC to AC converter and other converters are also being used for electric vehicle technology. For example, if the electric vehicle is being charged by the grid, right? Then AC has to be converted to DC. Then it has to be stepped up by or boosted by a DC-DC converter, and it has to charge a battery. In case if the electric vehicle is being connected to the grid, right? Then DC has to be converted to AC. Then it has to be connected to the grid. So. And then AC has to be converted to a other AC voltage, then it can be connected to the grid. Depends again. I can use a transformer or a transformerless system, etc. So depending on that, I can choose any one of the converter. But on the whole, these are all the converters which is being used for electric vehicle technology. So the basic requirement of electric vehicle converters are, it should be of a lightweight, high efficiency, small volume. I'll come to that point later. Low current ripple, the step-up function of the converter, and the controlling mechanism or the controlling algorithm which is being used for the converter. Fine. So while designing a converter, we have to take care of all the parameters. Based on that, I need to select a switch. I need to select the topology. Then I need to select the switch. So very, very important point is EMI. So all the switches should have a very, very low EMI, electromagnetic interference. So normally the present technology, not only for the electric vehicle, you take any conventional electronic system, they don't bother about EMI and EMC compliance. So it is going to be the major part of research for many industries, right? So electromagnetic interference, we have radiated emission and conducted emission. and it can be of two things. It can be generated by the component itself, that is intended emissions and unintended emissions. So because of this EMI, it may spoil the system by two ways. One is it will spoil the components, or otherwise it will spoil the corresponding components nearby to that component. Overall, it will become a heavy loss. So while designing a DC-DC converter, we have to select a switch or component in such a way that it should have a low or very low electromagnetic interference. So this EMI itself is a very big topic, and I'm not going to touch all those things, but this is a very important point in designing the converter. So advantages is like, as I said, even though it has many advantages, it has a very small disadvantages, like I need to bother about the design of heat sink, because it may heat up very easily and I need to bother about that, and there may be a loss, or there may be a loss in switch because of the high inrush current, and if at all, if there is, the switch itself gets stressed. Okay, the stresses may be because of the drivetrain component. And if there is a stress and the particular switch leg may blows off, and it will spoil the entire system. Okay, and during a high voltage or high step-up ratio, this converter may not work properly. We have to take a proper precautionary method to work during the high speed-up range or high step-up ratio range. So the DC converters for electric vehicle can be classified based on the storage capability, that like how the system can store its energy during. Hello, any doubt, participants? Hello, hello,
Hello, sir.
any doubt by the participants?
No doubt, sir. You can proceed, sir.
Okay, so the storage capacity, I mean, I was saying like how to select the DC-DC converter. So it has to bother about two main points, like main energy system and rechargeable energy system. So based on this energy system, I have to choose the proper DC-DC converter, and these DC-DC converter should be of a lightweight, small volume, high efficiency, low EMI, and low current bar voltage ripple, etc. So these are all the ways in which I can choose the DC-DC converter. So as I said, the importance of the DC-DC converter. See, here I have a transmission system. I have an electric motor. Either it could be a AC motor or a DC motor. So if I have multiple sources like fuel cell, supercapacitors, or battery, I can have an individual DC-DC converter, and I can connect it to a common DC link bus, or otherwise I can have a DC link capacitor. Then it can be connected to a DC to AC. Then it can be used for propelling the system. So these are all the ways in which I can go for different configurations of DC-DC converter. And there are two types of bridge converter: half bridge converter and full bridge converter. So again, this half bridge or full bridge can be selected based on the type of motor I choose and based on the topology I choose. So primarily the DC-DC converter can be classified also depending on isolated converter or non-isolated converter. Okay, so non-isolated bidirectional DC-DC converter or an isolated bidirectional DC-DC converter. So as of now, I have discussed about the type of motor and type of converter we have. And the main challenges of hybrid electric vehicles are the energy storage devices with high power to energy ratio. So the energy storage can be depending on type of battery we use, type of other alternate sources we use, either an ultra capacitor or a super capacitor or a fuel cell, and frequent shutdown and startup of the hybrid electric vehicle. How my system will respond while switching off and on very frequently? How my switches will respond? As I said, the switches may lead to some stresses, right? The stresses mainly depending on the drivetrain component. If I frequently switch on and switch off the system, the wear and tear of the drivetrain component may increase, and that also will lead to degrade the performance of the converter. Okay, and I need to reduce the size and weight and cost of the system, increase the efficiency, and advanced configuration for the propulsion system components are required to meet out the challenges. And very important factor is the safety aspect. One primary requirement for safety is the switchgear component, the fuse, the breakers, then SF fuse, switch fuse unit, DSF, disconnector switch fuse, SDF, switch disconnector fuse. So these are all the switchgear components which I can use it for the battery electric vehicle, and how my system will respond if there is any spillage. Okay, and if at all, if there is any accident happens, what will happen to the heavy battery? If it is a plug-in hybrid electric vehicle, I have a battery of 15 kilowatt hour of battery. So how my battery will react to it, and if will it be an accident because of the battery, not because of the crash? Okay, so these are all the safety aspects we need to bother. And in India, we have a PS4. They have a PS4 protocol being used, and we have FAME also. So depending on that, we have to bother about the safety aspects and design aspects of an electric vehicle. And the performance can be measured with the help of different parameter. One is acceleration and speed. Okay, and the second one is the range. So I have an increased acceleration, I have an increased range of electric vehicle, I have an increased speed. How long my vehicle will run without charging it? Okay, because now we don't have a public charging station, right? So battery charging infrastructure itself is a separate topic. I have a slide for it, I'll explain it. So how frequently I can install my charging station, or otherwise do we have any battery swapping methodology? So based on that, these parameters can be monitored. And emission, of course, the electric vehicle, when it is being compared to the conventional vehicle, the emissions will be very, very less. Now, how my battery electric vehicle will take over it? So emissions, even though it is very clear that electric vehicle will have less emission, but I have a slide to prove it. So these are all the pollutant: carbon dioxide, carbon monoxide, SOx, NOx, SOx, hydrocarbons, particulates, etc. You have very much saving if you use electric vehicle technology. And benefits of electric vehicle and hybrid electric vehicle, we have discussed it enough. Fine. So now we have one more important concept called as vehicle to grid and grid to vehicle technology. In Tel Aviv, there is a specific, you can Google it and you can see Tel Aviv, there is a road where in which the road can charge the electric vehicle while moving on the road itself, right? That is based on wireless charging or induction charging methodology. Similarly, assuming that your vehicle is being powered by solar when it is being parked, so the power generated from the solar vehicle is not being used anywhere, because solar power will run a battery will get charged. Once the battery is fully charged, what will happen to the remaining power which is available in the solar PV? So the remaining power, once the battery is charged, the remaining power can be supplied to the grid. So that is called as the vehicle to grid technology. Similarly, while on the go, from the grid, we can charge your battery or your car. That is nothing but grid to vehicle technology. So it can assume a two-way communication method. In a way, it can be called as a smart grid technology. In a way, it can be called as it will support the concept of smart grid technology by implementing the concept of V2G and G2B. We have to have a separate communication architecture, communication protocol for carrying out the concept of V2G and G2B. Still, it is under research level, but people can think about it. And in a way, your car can also be called as a prosumer, like the term what we use in the case of a smart grid technology. You can generate energy, you can also consume energy, so that you can supply whenever you have excess energy, you can always supply it to the grid. So the challenges are, as I said, it can be used only for a limited range. It requires long charging time, high initial cost. What the present day battery, I can use it for 3 to 4 hours. See, it is being supported by ICE, but now if it is entirely being run by a battery, how my battery life can be extended? And we have to make the people believe that it is one of the best vehicle. Okay, consumer acceptance and grid integration, these are all the challenges. So this is the battery swapping and fast charging methodology and rapid charging. Batteries, we have initial cost. So EVs today, you can see these are all the EVs available in the market now. It may look like a conventional vehicle. This is the conventional, not the conventional, the Tesla vehicle. Top speed 125 miles per hour. 24 miles, 244 miles without charging. That is the range. So soon you can see more number of cars like this. As I said, the electric vehicle charging infrastructure, there are two ways in which I can charge it, whether I can go for an AC charging or a DC charging. If it is an AC charging, if it is single phase or a three phase. So based on that, I can develop a battery charging infrastructure. So again, how I am going to charge it, whether I will charge it at the residential level or fleet level, then it can be called as home charging, or otherwise a destination charging, or otherwise opportunity charging. So there are three methods in which I can charge it. So if it is an opportunity charging, either it could be at the workplace or in the mall or in cinema theaters or in the marketplace or in the public places, etc. Or otherwise in the opportunity charging. If it is in the case of a parking station, I can charge it in the case of parking station, how much they will pay, how much I should pay for it. So these are all the different charging location that is available. We have a very good market scope for charging methodology infrastructure. As I said, it is a separate topic by itself. So limitations of EV can be classified into three: social problems, technological problems, and economical problems. Social problem, social acceptance, insufficient charging station. Technical problems, we have limited range, a long charging period, safety problem. And economic, as I said, high investment cost. Impacts of EV on electric grid. This is a very, very important slide. As I said, this one and battery charging infrastructure and EMI is a separate topic by itself. To complete the presentation, I have included this as one of the slide. What will be the impact of electric vehicle on your grid? Like it have a negative impact and positive impact. Voltage instability, increased demand, increased harmonic, voltage sag, power loss, overloading of transformer. Positive impact, facilitating smart grid, vehicle to grid, integration of RES, renewable energy systems. Impacts of environment, less GHG. Impacts on economy, lower operating cost, chances to benefit from vehicle to grid. Okay, these are all the impacts of EV. And these are all some of the industries who is working in the area of electric vehicle. So factor influencing in India, already I have discussed, but I have summarized it here. Infrastructure development, we don't have a proper revenue model for monetization. Building consumer awareness, growth and acceptance by the community. And we have to have a proper protocol like BS4 and FAME for implementing this concept. And in the conclusion, so we power electronics engineer or electrical engineer should concentrate on designing the drivetrain component and designing a proper EV battery backup charging station. And we have to have a proper BMS supporting the battery management system as well as ECUs. And we have to develop a proper intelligent microcontroller unit with an efficient control algorithm to control the power stage and optimize the performance of an electric vehicle. So without joining hands with the automobile engineer, mechanical engineer, it is not possible for us to give an efficient electric vehicle technology. So with this, I stop here. And before I conclude, I would like to show you people some of the book which I have published, which may be useful for your research as well as for your college applications. So this one is the book which I have published in CRC Press. This is like how electronics can be integrated into the textiles. And this is all about solar PV and wind energy conversion system. This was published in Springer, USA. This will tell you, we have given all the MATLAB blocks, etc. and the soft computing methods used in solar PV, fuel cell, etc. And here we have used 15 use cases to introduce the concept of importance of optimization. Again, all the MATLAB blocks, M code, everything is given in appendix. It is published in CRC Press. And here normally people use PSpice for teaching power electronics, but here we have tried with MATLAB, individual component and till application. We have given you how to use MATLAB for power electronics. It was published in Cambridge University Press, London. And here how automation can play a major role in textile machinery. And this book is all about from the generation till the renewable energy system, how power quality can be used, optimized, like power quality parameters, indices can be mitigated. Okay. And this book is all about how electrical engineers can use Python for implementing the concept of deep learning. Here also we have used 20 use cases. It was published in Wiley. And this book is all about artificial intelligence, which can be used for smart grid and smart city. And these two books are my latest book, published in Elsevier, UK. And this book specifically talk about power electronic converters involved in solar photovoltaic system. And another book I have forgot to mention. That book will tell you the simulation of electrical system using different softwares. Okay. So if you have any doubt, you can ask me now, or otherwise you can always email me in this ID. I'm happy to answer. If you have any doubt, I'm ready to answer now itself. Over to the organizers.